G'day everyone, I said I'd do a question on rectilinear motion, so I've done one here for you. This question took me far too long to do. My excuse is I teach this once a year, so I tend to forget a few of the little tricks here and there. Hopefully once you've done a number of questions, you don't make those same sort of mistakes, or really they were rookie mistakes, honestly they were. So, the question gives us this, and it just says, the first part says, show that it's simple harmonic motion. If you remember from the last video, simple harmonic motion is when the second derivative is negative k squared of the original, okay? So all I'm going to do is I'm going to take the derivative and I end up with this kind of ugly thing here. I'm then going to take the second derivative and I end up with this even uglier thing. But from there what I can realise is that there is exactly that, meaning that this part here is going to be my minus k squared part. There's the minus, right? And the 2 just carries on through, so that's not an issue. But the pi squared, 3 squared, that's really my k. In this case, k would really be pi over 3, which is always going to be the bit that's in here, because when we take the derivative, that part there is coming out the front twice. So my k is always going to be that part there, and it looks like that is the case here. So based on the fact that I could then write this as saying minus 2k squared sine of pi t over 3, that says that's now in the format of simple harmonic motion. So this function does conform to simple harmonic motion. It then asks for the period and amplitude. Well, this is not really a simple harmonic motion question. This is a Year 11 methods question, because you've just got to recognise that the 2 there is giving you the amplitude. Have a look at this diagram here. The 2 would be there, and that would be negative 2. So the 2 here is giving you the amplitude. And remembering this little formula here for the period of a function, k, again, same, is pi over 3. So pi over 3 goes in there, down here. Flip that, bring it up to the top line, the pi's cancel, we end up with 6. So that means the period of this function is 6 seconds, assuming it's in seconds. Amplitude of 2, period of 6. That allows me to draw this diagram here, amplitude and period. Now then with the next question, this is where this kind of is building to, how far does it travel in the first 2 seconds? Well, in the first 6 seconds, it's going to go 2, 4, 6, 8. So that wouldn't be so hard to do. One cycle would be 8 metres, I assume. In 3 seconds, or half a cycle, it would be 2, 4. Now remember that we're talking about here how far. So it's distance, not displacement. All right? After one cycle, its displacement is 0. But its distance is going to be 8 metres. All right? Make sure you make that distinction. This one sneakily says in the first 2 seconds. So this is where I made my mistakes and had to redo it 3 times. I've got to recognise that 2 seconds is going to be there. So it will have started one direction, stopped, and then started to go back in the other direction. But because it says how far, I've got to be alert to that. So when t equals 0, I was just double checking here, yes it does equal 0, yes it does start at 0. Logically that would be the case with the sine function. At t equals 1.5, so that is at the top point here, again, bit of a double check, it should have come out to 2, it does. Now both of those things there I probably didn't need to do. If you know what the function looks like, you could say, well, it's going to be 0 there, it's going to be 2 there, therefore in the first 1.5 seconds, it will travel 2 metres. The bit we really need to work out is this bit in here. We need to work out that particular height there, which I worked out through by letting t equal 2, and I came through to square root of 3, 1.732. So this point here is 1.732. Then what I've got to realise, to get my answer, the simplest way to do is to say 4 seconds minus root 3. Now we could work out the actual distance here that it travels, but don't worry about it. Do the whole half a period and then minus away the bit that you don't want. So then we come through to that answer there, which is the answer in the back. So after 2 seconds, it would have travelled 4 minus root 3 metres. This is kind of a standard question. This could actually all be in the non-calc. Probably unlikely, only because we've only got 50 marks there, but could easily be a non-calc question just to see your skills on a bit of differentiation and that sort of thing. Hope this one's helped. Catch you later.